G 10.1 Pythagoras' Theorem. Pythagoras' theorem, which is named after the Greek philosopher and mathematician, allows us to calculate the length of one side of a right-angled triangle if we are given the lengths of the other two sides. Before we look at the theorem, we need to know that the longest side of a right-angled triangle is called the hypotenuse. The hypotenuse is always opposite the right angle. So, what is Pythagoras' theorem? Let's start by labelling the sides of our right-angled triangle. The two smaller sides are labelled A and B in either order, and the hypotenuse is labelled C. We then need to draw a square on each side of the triangle. Next, we calculate the area of each square. The area of the square with length A is A squared. The area of the square with length B is B squared. And the area of the square with length C, the hypotenuse, is C squared. Pythagoras' theorem states that the area of the largest square, C squared, is equal to the sum of the areas of the two smaller squares, A squared plus B squared. In other words, A squared plus B squared is equal to C squared. This is true for all right-angled triangles. Let's have a look then at how we would use Pythagoras' theorem to find a missing length in a right-angled triangle. The first thing we need to note is that diagrams are not drawn to scale, so we cannot just measure them. Question 1. We need to calculate x. So here we have got a right-angled triangle. Two of the lengths are given to us, 6 centimetres and 8 centimetres, and we need to find the length of the third side, x. We need to start off by labelling the sides of the triangle. Remember that the longest side of the triangle, the hypotenuse, the side that is opposite the right angle, must be labelled C. I would recommend that you label this side first. The other two sides need to be labelled A and B in either order. So I'm going to label the 8 centimetres here as A and the 6 centimetres here as B. Once we have labelled our triangle, we need to write down Pythagoras' theorem. A squared plus B squared equals C squared. Now we need to substitute the values for the sides that we know into the formula. Well, we know that A is 8 centimetres, so we substitute 8 for A. And we know that B is 6 centimetres, so we change the B for a 6. And for C, well, we don't know what C is. That is X, so we can put an X in there. So our job now is to solve to find the value for X. So let's calculate the bits that we can. 8 squared, 8 times 8, is 64. 6 squared, 6 times 6, is 36. We can't do anything with the x squared, so we leave it like that. Now let's add together the 64 and the 36. That gives us 100. So we now know that x squared is equal to 100. So in order to find the value for x, we need to undo the squaring. That means we do the opposite of squaring, which is square rooting. So x is equal to the square root of 100, which is 10. So the length of the hypotenuse, side x, is 10 centimetres. I can check that this seems a reasonable answer because we can remember that the hypotenuse is the longest side, so x needs to be larger than 8 and 6. So I'm happy that my answer seems reasonable. In this question, all of the sides are whole numbers. We have a side of 6 centimetres, a side of 8 centimetres, and a side of 10 centimetres. This does not happen very often. When it does happen, it is known as a Pythagorean triple. So it's your turn to have a go at some questions like these then. In each question, you will be calculating the value of the hypotenuse, the length of side C. Some of the questions involve Pythagorean triples. However, for many questions, when you do the square rooting at the end, you will get a decimal. In these cases, leave your answer to 2 decimal places. Remember as well that you need to put your units. Start by labelling the sides of the triangle, A, B and C, remembering that C is the hypotenuse. Write down Pythagoras' theorem, substitute the values that you know, and calculate the bits that you can, and then finally solve for x by square rooting. Pause the video to copy the notes, to check your understanding, and to try the questions from I'm giving it a try. Remember to mark your work and reflect on your confidence. Unpause the video when you are ready to try the next question. Question 2. Calculate x. Give your answer to 2 decimal places. So here we have got a right angle triangle. We know 2 of the lengths, 27 centimetres and 15 centimetres, and we need to calculate the length of side x. So let's start by labelling our triangle. Let's label the hypotenuse first. The hypotenuse is the longest side and it's always opposite the right angle. So the hypotenuse is this side here, 27 centimetres. So I'm going to label that C. So in this question, we are not calculating the length of the hypotenuse. The other 2 lengths can be labelled A and B in either order. So I'm going to label this length here, the one we need to calculate, as A, and the 15 centimetres as B. Now let's write down Pythagoras' theorem and substitute in the values that we know. Well, we don't know the length A, other than it's labelled x, so I'm going to write x squared here. B we know is 15 centimetres, so I'm going to change the B for 15. And C we know is 27 centimetres, so let's substitute in 27 there. Now we need to calculate the bits that we can. So for this question, we are going to need to use a calculator. I can't calculate x squared, because we don't know what x is. 15 squared is 225, so I can write that down. And using my calculator, 27 squared is 729. So at this point, you'll see that this question is quite different to when we calculate the hypotenuse. We have got x squared plus 225 is equal to 729. We need to solve for x. So rather than adding together the 225 and 729, we need to subtract 225 from both sides to get x squared on its own. So x squared is equal to 729 subtract 225. So x squared is equal to 504. So now we know what x squared is, we need to undo that squaring to find the value for x. X is equal to the square root of 504, which is equal to 22 point, and I'm going to round to 2 decimal places, 45. And my units are centimetres. So the missing length in our triangle is 22.45 centimetres to 2 decimal places. Again, we can see that this is reasonable because the hypotenuse is 27 centimetres and the other two sides must be smaller than that. So it's your turn now to have a go at some questions like these. So you'll be calculating the length of one of the smaller sides of a right angled triangle, not the hypotenuse this time. Label the sides of your triangle, write down Pythagoras' theorem, substitute the values that you know, calculate the bits that you can, and then at that point you will need to subtract rather than add to solve for x. Remembering that the last step is square rooting. Some of the questions that you're going to get will be Pythagorean triples. With other questions, your value for x will be a decimal, so round it to 2 decimal places, and remember to put your units. Pause the video to copy the notes, to check your understanding, and to try the questions from I'm Building My Confidence. Remember to mark your work and reflect on your confidence. Unpause the video when you are ready to try the next question. Question 3. An equilateral triangle has sides of length 12 centimetres. What is the perpendicular height of the triangle? So in this question, we need to calculate the perpendicular height of this equilateral triangle. Now at the moment, we cannot use Pythagoras' theorem because we do not have a right-angled triangle. Remember, Pythagoras' theorem only works for right-angled triangles. So in a question like this, we need to search for a right-angled triangle that we can use. If I cut the equilateral triangle in half, like so, I now have 2 right-angled triangles. And what's more, the perpendicular height, the length I need to calculate, is this length here. So we can ignore the right hand half of the equilateral triangle and just focus on this right angle triangle here. We know the lengths of the sides of the equilateral triangle are each 12 centimeters long, so this length here is 12 centimeters. And because we have cut the equilateral triangle in half down the middle, the length at the bottom of our right angle triangle is 6 centimeters, half of the 12. So we now have a right angle triangle where we know the length of two sides and we need to calculate the length of the third side. So we can now use Pythagoras' theorem. Let's label the triangle with A, B and C. Let's start with the hypotenuse C. It's the longest side opposite the right angle. So the 12 centimeters here I'm going to label C. The two smaller sides can be labelled A and B in either order. I'm going to label the 6 centimeters here at the bottom A, and the length we need to calculate the perpendicular height that I've labelled X, I'm now going to label B. Then need to write down Pythagoras' theorem. And we proceed as normal. We substitute in the values that we know. So we know that A is 6, B is X, and C is 12. We calculate what we can. 6 squared is 36. We need to leave X squared as it is. 12 squared is 144. And now we need to solve for X. So we have to subtract 36 from both sides of the equation. X squared is 144, take away 36, which is equal to 108. So now we need to solve for X by square rooting 108. Which to two decimal places is 10.39, and the units are centimeters. So the perpendicular height of the equilateral triangle is 10.39 centimeters to two decimal places. Again, we can see that this is reasonable because it is a length that is smaller than the hypotenuse, so it's got to be a number smaller than 12. So it's your turn to have a go at some questions like these then. You will be given a variety of different problems to solve. In each case, you need to search for the right angle triangle. Once you have found a right angle triangle, you need to make sure that you can work out two lengths of the right angle triangle, and then you will be able to calculate the third length of the right angle triangle by using Pythagoras' theorem. So there should be enough information in the question to find a right angle triangle and two lengths of that right angle triangle. Then you can apply Pythagoras' theorem to find the third length. Sometimes you may have to calculate the length of the hypotenuse. Other times it may be that you have to find the length of one of the smaller sides. Either way, you start off by labelling your right angle triangle A, B and C, where C is the hypotenuse, the longest length opposite the right angle. You then write down Pythagoras' theorem, substitute in the two lengths that you know, calculate the bits that you can, and then solve for X by either adding when you are calculating the hypotenuse or subtracting when you are calculating one of the smaller sides. And then, of course, finally square rooting. Remember as well to give units for your answer. In some of the questions, you may need to go further than just calculating the third side in a right-angled triangle. For example, for this question here, question 3, I may have been asked to calculate the area of the equilateral triangle. In order to calculate the area of a triangle, I need the perpendicular height of that triangle. So we need to use Pythagoras' theorem first to calculate that, before using the formula for the area of a triangle. Pause the video to copy the notes, to check your understanding, and to try the questions from I'm Ready for Anything. Remember to mark your work and reflect on your confidence.